Hello friends, now we will see what properties are there of a tangent to a circle. The very basic property you know that tangent is that line which touches the circle at one point. Another very simple property you know that if line segment is joined from the center of the circle at the point of contact, then the angle is 90 degree. Another thing is that if two circles touch each other externally, one common tangent is there, and same is the case if the two circles touch internally. So what we see that if a common tangent is there, then the line segment from the center of the circle to the point of contact is making an angle of 90 degree and here also 90 degree. So this is line joining the centers of the circle is a straight line. We will now concentrate on very important property. From an external point to a circle, two common tangents can be drawn. See like this. And the properties we are deriving here is that their lengths are equal. The first thing you remember that length of the tangents from an external point to a circle are equal. Very important property. We are going to solve the problems regarding that only. See, and another thing you know, this is 90 degree. This angle is 90 degree. And what property, extra property we see here, this angle will be equal to this angle. So the important property you saw here, the length of tangents are equal. Now see question this, it is given that this side is 15, this side is 8. We need to find the radius of the circle. Suppose this is the center, of course this is going to be radius. And this is also the radius, and we know that both the radii, all the radii of a circle are equal in length. So this will be x, this will be x. Is it? Now see, this is 90 degree. We just saw in the basic property that line from the center of circle at the point of contact to the tangent is making angle of 90 degree. Here also 90 degree. This is already a 90 degree. So three angles are 90 degree. Fourth one is also a 90 degree. And two adjacent sides are equal. So what figure is this? This figure is definitely, suppose I am naming it ABC. BPOQ is a square. Why? All the four angles are 90 degree and all the four sides are equal. If I have taken this as x, this will definitely be x and this will be x. Why? You know, length of two tangents from external point B to a circle are equal. So BQ will be equal to BP. Now proceed. This is going to be 15 minus x. AP is equal to 15 minus x. Is it? Because complete is 15. And AP is equal to, can you tell me, from A, two tangents are drawn to this circle, that is AP, AR. And we just saw in the theorem the length of tangents drawn from an external point to a circle are equal in length. So we can write AR is equal to AP and 15 minus x. Now see. BQ is x, so QC will be equal to 8 minus x and QC is equal to, now tell me, QC is definitely equal to CR. Why? Because QC and CR are two tangents drawn from point C to a circle, and length of tangents from an external point to a circle are equal in length. Very important theorem. So this is coming out to be RC or CR, whatever you want to write. Okay, now we got this value, we got this value, so we can just write AC is equal to AR plus RC. So it is coming out to be 15 minus X plus 8 minus X. So it is coming out to be 23 minus 2X. Now by Pythagoras theorem, if AB is known to us, BC is known to us, we can find AC. Very simply, AC square is equal to AB square plus BC square. That is 15 square 225 and 8 square 64. That is what? 289. And AC is equal to 17. So we can just write this is equal to 17. And 2x is going to be 23 minus 17, that is coming out to be 6. 2x is equal to 6 and x is coming out to be 3. So we got the radius of the circle. Now see, in question this, we need to find the perimeter of triangle ABC. Perimeter means sum of all sides. Perimeter of triangle ABC is actually AB plus BC plus AC. Now see here, AQ is equal to, what is given we will see, AQ is equal to AR. Why? Because AQ and AR are two tangents to the circle from an external point A, and we know their lengths will be equal. So if AQ is 15, then AR is also 15. That is the only thing given to us. So in between, if something is needed, we will get by applying the appropriate theorems. Firstly, we should proceed. So AB can be written as AB and BC can be written as BP plus PC. And AC we cannot do anything, so we just write AC. Now you see AB, and can you tell me what BP is equal to? BP is equal to BQ. Why? From B, two tangents are drawn to the circle and the lengths are BP and BQ. From one external point, two tangents, they are equal in length. So for BP, I will write BQ because BP is equal to BQ, same theorem. And for PC, for CP, what I will write? Very much clear from the figure, that is CR plus AC. So we just got here that CP is equal to CR. That AQ is equal to AR, BP is equal to BQ, CP is equal to CR. That's only we are getting from this figure, and we have to make use of that to get what we want. So now you see that AB plus BQ is giving you AQ, and CR plus AC is giving you AR, and we know the length of AQ and AR both. That is 15 plus 15 coming out to be 30 units. If it is in centimeter, it is in centimeter, it is in centimeter, so centimeter. We got the perimeter of the triangle. And now see very important application of that theorem here in this question. First we need to prove that T is the midpoint of AB. So see here, TA will be equal to TP. Why? From external point T, two tangents AT and TP are drawn to the circle, first with center X. Now in second circle, you see that TB is equal to TP. Why? TB is tangent, TP is tangent to the circle, and they are equal in length. So TA and TB both are equal to TP. So we can write TA is equal to TB. What is the meaning of that? TA is equal to TB means T is midpoint of AB, and that is proved. Now we need to prove angle APB is 90 degree. Be careful. Now you see, if this angle is something, that angle will be same thing. In triangle ATP, TA was equal to TP, and if two sides of a triangle are equal, then the two angles, corresponding angles, will be equal. So if I take this angle as X, this will be X also. Now see, in triangle angle ATP, we have just written this angle is X, this angle is X, and now in triangle TBP, TB is equal to TP, two sides again equal, so two angles will be equal. If I take this Y, this will be Y, small y, don't be confused with the capital X and capital Y, the centers of the corresponding circles. Now, in triangle APB, we know one thing about the triangle, that sum of all the angles is 180 degree. So, we can write angle A plus angle P plus angle B is equal to 180 degree. So, angle A, X, angle P, X plus Y, angle B, Y is 180 degree. So, what we are getting? 2x plus 2y is equal to 180 degree. So, x plus y is 90 degree. And you know that x plus y means angle APB is x plus y. So, equal to 90 degree. We have proved by simple application. Now, go for the third part. Circle on AB as diameter touches the line XY. This angle is 90 degree, and we know the property that angle of a semicircle is 90 degree. That means AB is the diameter, then only APB will be the angle of semicircle. We have just proved angle APB to be 90 degree. That means AB is a diameter. That means P is any point on the circle. That is why it is becoming angle of semicircle. Of course, a line passing through P is the tangent. So, XY is touching the circle at point P, whose diameter is AB. We have proved it. Now, what we saw, just basic application of the basic theorem. We solved the problems in very easy way. Just continue to solve problems in such a way, you will find circle very, very easy. Thank you.